This conference will now be recorded.
Yeah, hi everyone. Actually, we have completed all the heap dump analysis part and how to take the heap dump and how to analyze the heap dumps. And also we spoke about, we discussed a lot about GC, the types of GC, like the GC algorithms, what types of GC that we have to use as part of our performance testing in baselining and benchmarking. Let us start with Java thread dump analysis today. Basically, the agenda of the thread dump analysis is like why I mean the basics of thread. What are the different types of threads you can have in any of the application, and why and when you need to take a thread dump. How the thread dump will be useful for any of the performance engineer to identify the root cause, and how many most important point is how many ways we can take the thread dump and how often we have to take. And there is again something called thread states, the thread states, how to read the thread dump and what do you understand by looking at the thread dump. Okay, so there are a few case studies as well that we can discuss, and apart from the case studies, I'll also explain you like uh, what are all the different bottlenecks that you can identify, like when you take thread dump. Okay, from you can take for any Java application, right? For every Java application you can take thread dump, and only the question is how often you can take it. Okay, so this is again, the thread dump is only talking about all the server applications written in only Java. And there are also when we talk about the case studies, we also have case studies with respect to Apache Tomcat server, WebLogic, WebSphere. There are many application servers. You can take thread dumps for any Java application, and there are some different unique methodologies in taking a thread dump. And most importantly, uh, the reason for uh, taking a thread dump is to solve the performance problems, like when you have a very bad performance from the application side, when the application is literally hanging, when the system is not responding, when you have a high CPU usage, and if your application throughput is not constantly increasing. There are many other factors to find all the different root causes for all the different abnormal behaviors that you see in your application. When during load testing, you go and take a snapshot of all the threads of your Java application. So basically this snapshot, right, this snapshot of all the threads will show what each thread is doing, and it will tell you the thread health and state, whether the thread is running or sleeping or it is parking, like what each thread is doing. Okay, and there are multiple ways. So this thread dump, it you can take on any environment. Okay, the first point is it is irrespective of any environment. It can be the test environment, QA environment, or prod environment. You can take it on any environment. Let me share my screen first. Okay, again, there is plenty of information on the internet, but I am preparing some documentation for you. If you can go through that document, it will be easy for you to understand all these concepts. Again, you have to install Java 8 and above version. You can try running all these things. JProfiler I have sent you, right? JProfiler, your kit, App Perfect Profiler, and Java Mission Control, JStack. Uh, you can work on all of these things, and you can just connect it to the remote host. It means that once you install some JDK and Java 8 on your machine, it means that there is some JVM is running on your local host. You can connect to your local host, okay, by just connecting it to the ID, I mean the process ID, the first thing is you need to know the process ID of that, and then you have to connect to that process ID, and you have to monitor all the different metrics with respect to thread dump. And thread dump will have so many issues like locks, blocked threads, deadlocks. To identify all of them, we use basically the thread dump. And you can take this thread dump on any operating system. Okay, you can take it on Windows, you can take it on very you can take it on every flavor of Linux. Okay, so before you understand the thread dump, right, you need to have the application understanding. If you don't understand the application understanding, how the threads are running or how the activities are happening on the application, you will not be able to read, you will not be able to get the complete knowledge on how to read the thread dump. Thread dump, you simply take a snapshot, or you can open any tool, and if you directly click on take a thread dump, it will take it. So once you take the thread dump, what information you will have in that? That is the point here. So once you take the thread dump, you will have all the different thread states. Okay, basically when you take a thread dump is a question. So when your application is very slow, if it is not responding, if your response times are high, if you see the high CPU utilizations, you will take a thread dump. And this thread dump will have a different information, like the different with different thread states. Okay, and there will be a unique information of every thread. It means that every thread will have a different stack ID, a thread ID. There will be a lot of unique information of that particular thread. You need to read the thread dump, you need to understand the thread dump, and you will see the status of the thread, whether it is running or blocked, or it is in parked state or something. But most of the thread states, like in thread states, you have new thread, you have a running thread. There is no problem with the thread that is newly created, or running thread also you don't have any problem. The only problem, the only slowness that you see in any of the application is only because of the number of total blocked threads. Okay, I'll tell you what is this blocked threads in detail. And also there is something called waiting. Waiting threads is also another problem for all the performance issues. So when you are looking at this thread terms, right, you need to mainly, the first primary point is you need to focus on all the blocked threads. I'll tell you why the threads will be blocked and how to take some necessary action on that. Okay, with respect to performance optimization. So now I have a question for you. Again, let us talk about. We have many reasons. There are some. All of you are experienced people, right? So tell me, when did you take your last thread dump and why? Anyone?
Yeah, okay. Yeah, application was slow. So just to
Mhm.
find out what the threads were doing, what were the states of the threads, so we had taken a thread dump.
So okay, how did you take the thread dump?
Thread dump from Visual VM, we have the option of thread dump. Button will be there in that Visual VM tool. So in that we had taken it.
Excellent. So any other answers? Visual VM is one option. You can directly take with Visual VM. No other answers you guys have? No one has taken the thread dump. Sorry, thread dump and heap dump. No one.
No, RK.
I think the other option is we can take it by using the kill command. Kill
Okay.
-3 the status ID.
Right, right. There are many ways to take a thread dump. Okay. So if you look at the thread dump here, so it is very simple actually. You need to just right click on it and you need to click on thread dump. If you are creating a thread dump, it will take the particular snap of all the different threads that are running or doing what. So if you look at this thread dump, you need to understand what each thread is doing. If you look here, it is giving you a thread ID, right? Thread ID is unique for each and every thread. There is something called NID. This is also unique. So if you look at this particular thread, okay, so what it is doing is it is showing as running. Okay, so likewise you will have different status here. Like to understand, if you look at this thread state is timed waiting. It is waiting for an object monitor. So this is also, so there is no blocked thread here. If you see, there is some waiting thread, there is runnable thread, but this is a very sample thread dump, but this is not the case with real time. When you are doing a load test, right, you will have a lot of information in the thread dump, and a complicated thread dump will have a more than 1000 to 2000 lines of dump file. If you look at that file, you need to check. The first point is you need to check from how many number of blocked threads you have. Okay, got it. So then after that, there is something called waiting threads. There is something called timed waiting threads. And again, the last one is the last priority is a sleeping thread, which can give you some kind of slowness. But new thread and running thread will not give you any performance issues. But before you take all this thread dump, you need to understand the application right from the beginning, the application complete infrastructure, technology stack, and you need to take more dumps in short duration to understand what exactly happened. There is a question, right? How often you need to take this thread dump? If you are continuously seeing so many performance issues, you have to take a thread dump for every 10 seconds. That means that is the default. That is the default practice, because if you take a thread dump for 1 hour, you will not be able to read it. It will capture a lot of information. So, for example, if you're running a test for 4 hours, and you are seeing the issues from 2 hours 10 minutes to 2 hours 20 minutes, so you will slowly start taking all the different thread dumps at this duration, right? So again, you can take this thread dump on any environment at any point of time, but again, you need to, the only agenda here is we are analyzing the agenda of taking a thread dump is we are analyzing fixing the blocked and waiting threads. So if we talk about few case studies, right? If we take one specific case study. Now again, yesterday we were talking about the GC part, right? The first abnormality is always with high CPU. Every time you run a test with 1 hour duration or 2 hours duration or 3 hours duration, or even if it is an endurance test which is a long run for 5 hours duration, 5 days duration, the first common thing every time you see in a load test is a high CPU utilization. There will be n number of reasons for this high CPU. Yesterday I told you, right? It can be because of high stop the world events. It can be because of longer GC process, longer GC execution time. You need to fix the GC thing. You need to fix the memory issues. Then you need to see the CPU how it is working. If not, the second immediate action that you need to take for high CPU utilization is you need to take a thread dump. Okay, you need to take a thread dump and you need to see what each thread is doing and what is the health of a thread. which thread is taking high amount of time. Okay. So the second case is there is something called deadlock. Any one of you have an idea what is deadlock?
Yeah, deadlock. Thread A is waiting for thread B, where thread B is occupied a resource which is occupied by thread A. It's like A is waiting for thread B's resource. Thread B is waiting for thread A resource.
Right. For example, if a user one is there, right? He is actually doing some task and is holding some resource. Once he completes the task, he has to release that resource, right? Now, once the user one is releasing that resource, user two can access that particular resource. Until and unless he releases that, the user two will not be able to access this resource which is actually accessed by user one. So the thing here is a thread will be blocked. Okay, one thread is blocked to acquire a resource which is held by other blocked threads. So when this situation happened, we will see a message like one deadlock found. Okay, there is no appropriate fix for this one. Only fix is the developer has to write a code in a way that no object is holding a resource for a very longer time. If a particular user or a thread is holding some resource, once the task is completed, it has to release that particular resource. If it is not releasing that resource, if for example user one is doing some activity, it is holding some resource and it is not releasing. Now user two want to do the same activity. So he cannot, the user two is not able to take that resource from user one, which is already holded by user one, right? So in such cases, there is a situation will happen like the deadlocks will be created. So to analyze all these deadlocks, to eliminate all these deadlocks, we understand such scenarios only by taking thread dump. And if you take another case, right, another scenario, which is called resource contention, it means that two or more resources, like if you have plenty of objects, they'll be, or I mean, we will talk only in the thread concept. Two or more threads will be fighting for the same resource. So when that happens, as a result, we will see a very bad performance from the application side. That is nothing but resource contention. So when someone is asking you, what do you do? For what reason you are taking a thread dump? So you can tell them that to understand the high CPU usage, or to eliminate the deadlocks, and to avoid the resource contention, and there is another possible cause. This is also one of the important possible cause, out of threads. When there is no room for when there is no room for running all the additional threads that they come in, so it will run out of threads. If you want to increase the performance of your application, just by increasing the number of threads allocation will not be sufficient. Okay, for example, you have to run 5 tasks. Okay, but only 2 threads are allowed concurrently. In such case, task the user, I mean, if two threads are allowed concurrently, and if you have to perform 5 tasks, and thread 3, thread 4, thread 5 have to wait until the task 1 and task 2 are finished, right? If you increase the concurrency, then only the application performance will improve. If you have 5 threads, and if the concurrency of that 5 threads is very low, like if you have only 2 concurrent threads are allowed, and the remaining 3 threads has to wait until and unless the 2 concurrent tasks are completed, that means that you already have a waiting thread, which will start creating some kind of performance issues. So if you want to understand or investigate the high CPU usage, or the different classic deadlocks, if you want to understand the resource contention or out of threads, you need to go back and check all the log files. Okay, you have a different log files in the web application server. You can go back and see if you have a high CPU usage, you have a log file with name called cpu.log. Okay, and if you want to check the deadlocks, you can go back and see the log file with name deadlock.log file. Okay, in the same way, for resource contention you have resource contention.log, and for out of threads the log file with name threadpool.log is the file name. You can see, you can check the total communication that has happened between the client and server for all the users with respect to threads. Okay, so the thread dump analysis, right? uh, it is very easy. First point, okay, you don't need
Uh,
any third party. Yes, please.
where to find this thread pool log? How
I'll
to
show
get
you
it?
in I'll show you in WebLogic when I show you the deployment, right? The deployment of the war file, I'll show you there.
Okay.
Okay, I'll show you how to configure the thread dump. Sorry, thread pool connections. So basically the thread dump is, it will work for any Java application. Okay, it can be taken on any of the environment, even in production, and you need not go with a lot of preparations to take a thread dump. You really don't need complex preparations, and no third-party tools or softwares are required to take a thread dump. Everything you have JVisual VM, JConsole, or JProfiler, your kit profiler, app kit profiler. There are also commercial tools, but you also have inbuilt tools from JDK that you get from your Java installation with Java 8 and above Java 8 versions. In Java 1.7 also, I think we have few inbuilt uh, uh, we have inbuilt features that allow us to take some kind of thread dumps. Okay, and we have there are some serious performance problems. Okay, you can't improve your application performance by 10% by taking a thread dump. So thread dump, by just taking a thread dump, it is only that it will give you a clarity of why the performance is slowing down, why the performance of an application is really slow. But you cannot use this thread dump to improve your application performance, not even by 10%. You take a snap of a particular thread, you check for the blocked threads, you take a snap, you send it to the developer, and you ask him why is this happening. Okay, so you always need to first consider Java memory use and garbage collection behavior as a possible root cause. Thread dump is the second priority. The first performance improvement or optimization that you have to implement is uh, the Java memory issues. Like you need to check all the different heap memory issues, how often the GC is happening, or you need to check the garbage collection behavior, and you need to give the possible root cause to improve the performance. After that, the second thing is you take a thread dump. Okay, even if someone asks you a question, what is your call on high excessive CPU spinning? The first thing is you need to check all the different processors. Okay, you will also check if memory is running, if memory is increasing in parallel with CPU or disk. That is the first thing. The second thing is you check for the number of processors, you check for the available memory. Then the third thing is, then you go with heap dump. Okay, then you monitor GC, all metrics of GC, and the last step is you take a thread dump. This is how you go. But before we talk that, I would like to ask you a few questions in this class today. So most of you must be there in performance testing since years, right? So can anyone of you tell me, if you take one scenario as a troubleshooting activity, so many people, I ask many people and many students ask me this question: what is the relation between hits per second and throughput?
Hits per second is when we make a main page as a request, that may be invoking multiple requests as part of the resource calls, images, JavaScript, CSS. So every request, every minor request, dependent request, everything is considered in the hits per second, every hit. But throughput is overall bytes transferred from server side over the network to the client.
Okay.
Hits per second is nothing but a request from the web from user side, and throughput will be a output. I mean, response for those requests.
That is fine, but my question is the relation between hits per second and throughput. Hits per second has to increase with throughput or decrease with, or it has to decrease with
Should be
throughput.
proportional. Both should be proportional.
Is
Okay.
Directly proportional.
Okay, they are directly proportional and they are working. It means that everything is working as expected within the specified SLS. So if they are not directly proportional, what can be the cause of it?
The server is not able to process those requests.
Which server?
Sorry?
Which server?
Application server, and it might not able to respond for those many users.
Okay.
It can be a web server also, for that matter, or we can't say where is the problem without analyzing, right? Bottleneck.
I don't
So,
think per second
no.
the web server will be the issue. It should be from application server.
Most of the times, the first primary issue is it can be because of the network bandwidth issue. Okay. The second cause is the web server. The third cause is the application itself must be having the issue with some coding related issues or something. Okay, hits are increasing and throughput is not increasing is due to only because of the application issues. So it can be because of the application deployment, or if the application code is not efficient, and we will be continuously receiving the exceptions which impacts hits and low throughput. So the hits per second and throughput must be always proportional. As you said, with having a proper APM solution, after monitoring all of them, you need to jump onto a conclusion why this is not proportional. Okay, if it is directly proportional, then you don't have any issue. If it is not proportional, you need to look at all the metrics from the web server, application server, and also you need to look at some network latency metrics to understand why they are not proportional. But mostly the problems are because of the network bandwidth issue, or it can be because of the web server, and most importantly, most of the issues are from the application server. Okay, if you have application issues, you will be seeing all the different kinds of performance symptoms. Now, if I talk about
what
yes.
issue you might get from web server, RK?
No, general thing is like, see, the whatever the web page that has been served right from the application server, when you get back when you get a response back, the web server has to serve you the JSP page, whatever the page that you see physically sitting in front of your laptop or a desktop, the page that you're seeing because of that web server. So this web server will, because if you have some network issues or network bandwidth issues or any traffic shaping issue, the content will not load and you will not be able to see that page on the laptop screen. So whatever you see when you click on next, when you go back, when you refresh, whatever you see on the screen, that happens because of the web server. So the web server will not be able to serve the pages to the user, and he'll not even able to see the images, and you will simply see a cross mark on it. The page will load, but the content on the page will not load. You can see such kind of issues. Okay. And if I talk about if I talk about another scenario, like the relation between the running users and hits per second. What is the relation?
Direct proportional.
I am hearing a lot of disturbance. I'm sorry. Sorry, can you repeat that?
It's also same.
Yes, this is also same. A simple answer is if the application is having too many problems, right? The application will not respond well, and they will not be. You will see the values inversely proportional if you have such issues. But the expected behavior of the running users and hits per second is if the users are if the users are gradually increasing on the application, obviously the hits will increase, right? It is simple. So if you talk about throughput and response time,
It should be inversely proportional. Response time should be lower to achieve a higher throughput.
right. As per the standard, it is always they should be inversely proportional based on boundaries, depending upon what testing pages or what type of requirements you have. And if I talk about running users and connections,
That should be proportional.
right? So these are all the main important relations. Okay, response time and throughput, hits per seconds, and uh, hits per second and throughput, or hits per second and running users, or running users and connections. You'll be asked with so many uh, relations, but there is no one answer for everything. Like if you want to define the relation of two different metrics, there can be some n number of possible causes for that. Okay, you cannot simply tell only because of this issue this is happening. You cannot tell that. Okay, so the first thing that you do is you try to fix the Java memory use here, and you try to fix the garbage collection behavior, and then you take a thread dump, and you don't have the problem with the thread dump analysis is you will not have any GUI. You have to read all the thread dump file, and you have to check with type of status. Even if you take the JProfiler, right? So install it. Right. So if you install Oracle, right, you can configure the Oracle database from here. What happened? Anyone of you installed JProfiler?
Yeah, okay.
Is it working or giving any issues?
Let me try. But I don't have sample files.
Okay, allow me a minute.
It's working for me. Okay.
Yes, it is working now. It is working.
Okay.
So I'm not creating any simulation here, but you can directly see the threads, right? If you can't read all the complete thread file, you can directly go here and you can see that the running threads that you have or the blocked threads. This is the danger part. This is the first thing that you have to worry about. Okay, you have to worry about the blocked threads and you have to worry about the waiting threads. If you're fixing the blocked threads and if your waiting thread is waiting for a minimal time as expected and it is serving the need of a specific user with respect to performance, then you don't have any issues. You can JProfiler is I'll take a class separately for JProfiler to show you how you have to use and how you have to consider all the metrics, different metrics. Okay, but JProfiler is a different session. But when you come here, when you go to threads, you can directly check the thread history, thread monitor, and thread dumps. You can directly take a thread dump from here. You do not worry about how you have to take a thread dump and what does the thread dump do, like what are the different ways. Don't worry about all of that. A simple right click and selecting take a thread dump will help you. Okay, so thread dump you can also, the only thing that you need to take a thread dump is the process ID. For the process ID that you want to take a thread dump, okay, the first step is you need to take a process ID. The Java process ID, if you know it, right? Once you know it, you can directly go back and you can take the thread dump. And if you talk about the most common root causes for performance problems with respect to thread dump are, there are so many systems which sit on the back end. Those systems will get overloaded. Okay, the application will wait for the response times. If you take the database or the middleware, or if you take some areas of all the different web services that we have inside application server, it is only because of the backend systems overloading. When they are overloaded, most of the application threads will be in struck state, or they'll be in waiting state, or some of the threads will be in blocked state. And there is a different problem called locking problems. Okay, basically how these locking problems will happen are, uh, these locking problems are different parts of the application code, and they will not allow the threads to execute in parallel. So that what will happen is the concurrency on the application will get reduced and the performance of the application will be obviously slow. Okay, and other different performance issues are, like you will have a very bad memory sizing. The first thing, the heap will get affected. If the heap is getting affected, you will have garbage collection getting affected, you will have high pause times, and you will start seeing so many memory leaks because of the same object which is not being used is continuously occupying the memory. Then you will see a memory leak inside the application. And if you have an improper garbage collection configuration, right? If you have improper garbage collection, what will happen? Anyone?
Memory
For example,
leaks.
right? If I have a very bad configuration of my heap, what will happen?
Out of
Simple.
memory.
Excellent. So
Okay.
out of memory you'll get, right? If I'm giving a bad memory structure, I give a very small size of hidden, or if I give too much of older, I mean, or if I give my heap as same as physical memory that is available, you will seeing all the errors. Okay, so and other common root causes for performance problems are mostly the resource constraints. I told you, right? If your CPU started spinning, if your CPU is very high, you need to think in different directions. You need to investigate with all the metrics. High CPU utilization will not happen only with one specific metric. It will happen with some 9 to 10 metrics. I'm not saying that all the 9 different metrics are causing the problem or spinning the high CPU. But what you have to understand here is, if you see a high CPU, there will be n number of reasons. It can be any one among these n reasons. Okay, it is not that it is because of heap, it is because of GC, it is because of threads. It is not that. It can be 1 or 2 or 1 or 3 reasons for a high CPU spinning. So you always need to continuously check. You need to check the comparison of CPU. You need to continuously monitor the operating system memory, the input output rate of disk, and the network. So, and I will not talk about virtualization here, because virtualization also will create some kind of problems with respect to database. And more precisely, there is something called thin provisioning of virtualization, where you will have too much of latency issues. So we'll not talk about much on that. That is another concept. So every time when you see an application is really slow, when you think the performance of the application is not expected, the first idea or the first input that you get, that every performance engineer has to think about the application code. What if you have to trace everything that application code does? You need to see what the application code is doing. How do you do that? There will be, if I say an application issue is from where? It is from the application code or application deployment or war file deployment or configuration in not having a proper configuration. So if I say that my application is performing not up to the mark, so I have to my plan is to trace everything that application code is doing. So how can I do that?
We need to see application logs
Okay.
to understand whether it is writing any useful information about the errors or abnormal conditions.
If you look at the JProfiler, there is something called instrumentation, right? Basically bytecode instrumentation. You know what is instrumentation?
Yeah, instrumentation is like the code will be instrumented by using some markers kind of thing.
Yeah, any profiling tool has instrumentation, but if you want to go with in detailed instrumentation of any of the application code, there are various commercial tools that are available in the market. So we have many in-house tools from CA actually. So we have many tools like where we can instrument the complete code. But again, JProfiler also will help you to instrument the code, but um, it is not to the level that you are expecting, but it'll instrument the application code, and it can help you with which parts of the code in the application is running for a very long time or very frequently. Okay, so anyhow, the performance engineer is not really interested, or he'll not get an opportunity to work with an instrumentation part, and that's not actually our job. Okay, so if the performance problems are very serious, so it would be a strong consideration to go with the instrumentation part of the application code, and they will check which part of the application is running really slow and how long it is running. That is one part. But when coming to the Java thread dump, so this thread dump is just like to see what is happening with all the threads. If you're fixing all the threads, to some extent the performance will behave up to the mark. Okay, so if you take a thread dump, basically this thread dump will have a snapshot of all the code executing at the moment. Okay, there is no trending history. You cannot it is not like you can take a thread dump of the entire day. A thread dump has to be taken for a very short period of time. The reason is because if you take it for a very long time, even you will not understand what happened. That is like you'll have thousands and thousands and lines of code where you'll not be you have to check it manually, or you can simply, if you have a thread dump file, you can go to fastthread.io. You must be aware of that online analysis tool, right? Don't know how many of you
Yes,
know this one.
yes. I think not sure whether earlier it was called as gcec.io also, right? I think this is same.
Uh,
Same thing. I think.
no, GCAZ is like for analyzing all the GC logs also.
Easy.
GCAZ
Okay, this
is
is thread. Not
that is,
thread.
this is
Got it.
thread.
Okay.
Okay,
Got it.
so you need to add see the you before you upload the format, right? You need to, before you go for interviews, some people will ask you what is the extension of the thread dump, what is the format, what is the extension of heap dump.
You mentioned hprof or something. I don't remember. Forgot.
It is not something, it is hprof only.
Hprof. Okay.
It is hprof. Dot hprof is the extension for thread, sorry, heap dump.
Okay.
Okay, if someone will ask you, I mean, some people can ask you what is the extension of this one. Okay, if you, when you say that I worked for this one. So the snapshot is completely textual. Okay, it will be completely in the text format. It will give you all the different states. If you look at here, uh, basically I'll send you this document. Yesterday's document also I'm supposed to send, right? That I'll share it today, this one and that one. So basically you take a thread dump to identify the thread contentions, the contention that happens between the resources, and the types of deadlocks, to analyze which thread is doing what, to also monitor the thread actual health. Okay, these are all the different status that we have. New is nothing but the thread is just created, but it is not processed. It is just created. For that, you can see the status of a thread as new. The runnable is nothing but the thread is occupying some CPU and it is already processing. The thread is performing some task, and now it is running. Okay, and when you say blocked, the thread is waiting for a different thread to release its lock in order to get the monitor lock. We'll talk about this more in detail on Monday. So we'll take one thread dump and I'll show it to you what is lock, what is monitor, and how it will obtain a lock and a monitor. Okay, what is the relation between how the monitor is related to a thread, and how a lock is obtained by a monitor. So I'll talk about all of that on Monday. So in waiting, you have many types. It can be parked, or it can be idle, or it can be timed waiting. You have different states here. I'll tell you the importance of each and every individual state. And there is timed waiting. The thread is waiting for for some time. That limit also we'll talk. And okay, if you go here, when you take a thread dump, uh, I told you, right? The thread dump is basically very big in size. Basically, when it is a textual file, if you are taking a thread dump for every 5 minutes, whatever you see in the text format is very, very large. You have to manually scroll and see what each thread is doing. If you do that manually, it is a very time consuming task. So when you run a test for 2 hours or 3 hours, your test went very well up to 1.5 hour, and in the last 30 minutes, you are seeing issues, right? In the last 30 minutes, at which point you are seeing this issue? You will understand by looking at some metrics with the graph, right? You see a sudden spike, you see some abnormal behavior, you see some values that are increased ad hocly. So what you do is you take that particular time frame. Okay, for example, 1 hour 41 minutes to 1 hour 15 minutes is the place where I have seen multiple spikes. So for every minute, what I can do is I can take a thread dump. I can take a thread dump for every minute, and for every minute, to understand it in detail, I'll take a thread dump. 5 to 6 thread dumps for every 10 seconds interval you can take, or every 5 seconds interval you can take. For 1 minute, you can take, for every 10 seconds, you can take one thread dump to see what happened. When you see this thread dump, you will have all these details. Initially, you will have the thread name. Okay, sorry, just a minute. You will see the thread name, the priority. Okay, there is something called priority, which will give you the priority of the thread, and thread ID. Thread ID is unique. Okay, so thread ID, only by giving the thread ID, taking a snap of the entire information, the status of that thread, you send it to the developer saying that this thread is a troublemaker. Okay, so you can directly, if you know the thread ID, you can see all the CPU usage, memory usage, and what are all the different other resources that are being accessed by that particular thread. So in such cases, to understand all that utilizations, you need thread ID to investigate. So thread status, I already told you, right? It can be blocked, it can be new. You will see the thread status. Based on this thread status only, you will send the information to the developer. And the first priority is always the blocked threads, and the second priority is the waiting threads. You don't have any problems with new threads or running threads. And the third priority is also about the running threads. Running threads are also a troublemakers at times. I'll tell you when. Okay. So these are the different points. We take a thread dump when the thread is unable to obtain a lock, then the thread will be blocked. Okay, when you have a deadlock status, when you have a continuous waiting. Okay, waiting is also, if the thread is waiting for uh, 10 minutes or 15 minutes, you need to go and see for what reason it is waiting, right? Why it is waiting. So, and another thing is, one straight forward answer to take you a thread dump base. If your application is slow, you take a thread dump. If you see high response times, you take a thread dump. If you see high CPU utilizations, you take a thread dump. In one liner, if your application is not behaving as expected, or not within the SLA limits, or not behaving with respect to the industry standard response time numbers, like 3 to 5 seconds, you take a thread dump. You simply take a thread dump, that's all. Okay, so this is a complete overview of it. Is a basic level of thread dump. There is a lot about there is a lot to talk about thread dump. This is basically you can take this like a basic class for thread dump. So because when we go and take all the thread dump, right, now you should be able to understand why I'm taking thread dump, what is the different type of information that I see in thread dump, and if how to effectively read the thread dump. And after reading that thread dump, how can I understand the different performance issues? That is what you have to understand. So and most importantly, the last point is, how does a Java thread dump help? Can anyone tell me? In what way, if I take multiple thread dumps, what should, being a performance engineer, what should I do with all of them? In what way it will help me?
We can find which threads are in waiting status for long time, or which is blocked, or which is deadlocked.
Okay.
So
So we can
that,
compare. Sir, we can compare like if you have taken 3 thread dumps or 2 thread dumps in 10-second time, less time, then we can compare like if any thread which is running in both the threads, so that
Right.
we,
Taking a frequent thread dumps, and if you compare all of them to see if the same thread is behaving in both the thread dumps, behaving same in both the thread dumps, right? So you need to check the consistency of that particular thread. You'll have one single thread which will be which will be a bottleneck for your entire load test. If you take some 4 to 5 thread dumps, and if you look at one thread ID, say 375410, which has a continuous lock in all the thread dumps, it means that that is a direct culprit. Got it? So taking multiple thread dumps, looking the common things in all the thread dumps, understanding all the different thread status that stays blocked because of a particular thread ID or because of a particular thread. If it is there from 1 hour 40 minutes to 1 hour 51 minutes, so that is creating a problem. If that is getting fixed, obviously you will not see this spike. Okay. So thread dump, again, the limitation of a performance engineer of learning thread dump is only to understand, to identify, to address all these issues to only the development team. You will not have complete control over the thread dump, and you will not be able to optimize or touch or do some kind of enhancements to optimize the code. You cannot do that, right? But only thing from a performance engineering point of view, what you need to know is different types of threads, different states, what do you understand from the different states, and how often you have to take a thread dump. You have 8 to 10 ways of taking a thread dump. Using a kill command, you can use JStack, you can use JStat, JMap, JHat, JVisualVM, JRocket, JProfiler. Okay, likewise JConsole. These are all the different options that are available for taking a thread dump. We will see all of them. I'll explain you all the 8 to 9 thread dumps, and I'm also trying to install WebLogic. Let me try to install the WebLogic machine here on the CentOS machine. Once I install, right, we will try to take a thread dump using some ID from here. Okay.
Yeah,
Yes.
do you have any thread dump snapshots which has some issues? Can you share those?
I already have, but those belong to COE team. I don't think so. I'll be able to share all of them, but I'll try. Okay.
At least
I'll
one
give you
or
one
two.
sample. One thread dump and one heap dump I'll try. Okay. But make sure that you're not sharing it with anyone. Okay.
Sure.
So this is a very basic level. We'll talk more about thread dump on Monday. And after that, we'll go back to the course content once. And again, I am seeing so many PDF files, materials on internet. Okay, so what they are saying is Java performance troubleshooting guide, which is of 400 pages, 450 pages. Don't read all of that. You identify the content which you really need for your experience and prepare accordingly. Okay, whatever. So if you have one profile where we have added, right? Real time we did not talk. We'll talk about real time, but again, we discussed everything theoretically here. Thread dumps, not thread dumps, till heap dumps, garbage collection. We will talk about how to collect GC logs, analyzing GC logs, and basics of memory has been already discussed. I mean, I have already shared the document. This out of memory and all, we will use different profiling tools. Okay, we will use some simulators, and we will hit the WebLogic server with some sample load, and we will use JProfiler. We'll use YourKit. I have also shown, okay, YourKit was not there. JVisual VM, and we will use all of them. And after that, performance, .NET performance will be discussed only theoretically, because I don't have any server, or I don't have anything installed on my machine. .NET will be discussed only theoretically, but all the major issues will be discussed, okay, from engineering side. When we come to database, right, database will talk about AWR report, automatic database diagnostic monitor, SQL query optimization, and AWR report, ASH, active session history. Okay, this is the most important part again. Before you attend this class, learn some database basics. Okay, then you can attend this class. Just go to a very high level overview. And the last part is client-side performance testing. I have downloaded a tool called Lighthouse. Okay, that is an open source tool. I'm not talking about GTmetrix. Now, client-side performance testing is a mandatory practice for every performance testing project. Okay, again, if you go to GTmetrix, measuring the client-side metrics is not this one. Okay, this is not client-side performance testing. GTmetrix is a client-side performance testing tool. If you paste the URL and it will give you some suspects and it will give you some default report, this is not client-side performance testing. Client-side performance testing is different. There is another tool for that. We'll talk more about client-side performance testing, which is a emerging trend from the last 2 years in performance testing. Okay.
And
So
RK,
Wiselow is also.
There are many tools. You have so many tools. If you go with the tool specific explanation, you will have hundreds of tools. But for client-side performance testing, GTmetrix is the excellent tool for now.
And RK, we have a tool called Web Page Tester, right?
Web page test also you have. You have Wiselow from Yahoo. Okay. Before you attend my class, allow me a minute, please.
what are the other tools you said, RK?
1 minute. Web page test, GTmetrix, Wiselow. There is something called
And there is another tool called sitespeed.io that is also recently people use.
What is site?
See,
Sitespeed.io.
if you look here, these are all the tools that I have used. The PageSpeed, which is from Google, PageSpeed, Web Page Test, and you have browser plugins, and I have used GTmetrix. These are the most commonly used tools. Wiselow from Yahoo, but I would suggest you the GTmetrix is the best tool. Okay, this is the recent article that I have posted for client-side performance testing. Before you attend the session, you can go through this article. Okay, I have clearly explained all the scope, everything. You can go through and you can.
Can you ping that URL? You share that
Yes,
URL.
done. All right, we'll meet on Monday. So I'll send you both the documents today. Don't worry about the thread dump for now. Prepare heap dump, prepare GC. If you have any questions, you prepare it on Saturday and Sunday. And if you have any questions from GC or heap dump, you can ask me on Monday. Okay.
Sure, RK. Thank you.
All right, sir. Thanks all of you for joining. Thanks for your time.
Yeah. Thank you, sir.